Example 11, Chapter 6. Steam at a pressure of 1.4 temperature is flowing in a pipe as shown in this picture. Connected to this pipe through a valve is an evacuated tank. So tank at first. Think that M1 equals to 0. The valve is opened and the tank fills with steam until the pressure is P. And then valve is closed. The process takes place adiabatically. And the kinetic energies and potential are negligible. Also equals to 0. Determine the final temperature of the steam. For the selected control surface and control volume, we can write the energy equation in transient form, which was gas, the inlet mass energy equals to the inlet mass energy, outlet mass energy, plus the state 1 and state 2 of control volumes energy and plus work down by the control volume. For the selected control volume, the adiabatic process, difference between potential and kinetic and potential energy, work also is 0. M1 also equals to 0. The potential energy for the second also is equals to 0. For the inlet mass, we have MIH I equals to M second U second. For the continuity, sigma Mi minus sigma ME should be equals to M second minus M1 0 0 MI ME. So this equation can be reduced as HI equals to U second. We can extract from the tables for the steam at pressure should be checked with table B11 for temperature 300. P saturate is megapascal, it is greater than the P pressure of line, which is 1.4 megapascal. So this is superheated, and from table B13 the H equals to H I. So use to the equals to HI to obtain temperature. We should first check with table B12 for pressure kilopascal, HG UG equals to, you can check with the book if you have. It is smaller than HI, so we have also superheat. Now we can use table P13 for the pressure, and U equals to the approximate temperature can be calculated with interpolation. Centigrade. This process is adiabatic, but we must examine the two boundaries for work. If we visualize a piston between the steam that is included in the control mass and the steam that follows behind, we readily recognize that the boundaries move and the steam is the pipe does work on the steam that comprises the control mass. The amount of this work is there is work due to compressing the gas. MP1 1. So we can write the kinetic energy equation for a control mass. We can calculate that. We know we have no from this relation. which means that as the previous conclusion. So the result is true. This is the end of this example.